Shall we start? Good morning, all of you. I am T. Sarita, JL Mathematics. Today we are going to learn 1B. In 1B, chapter number is 9, differentiation topic. We are going to learn. So this is our chapter, differentiation. Differentiation, right? So first we will start with what is differentiation and why we will learn this differentiation. Differentiation or derivation both are same, right? So what is first we will learn the definition of differentiation, right? Differentiation or derivation. Derivation of a function. Derivation of a function. Now, before going to learn, so now first we will take one graph. Let us say this is a graph, y is equal to f of x. So this is x axis and this is y axis. Okay. Now, if I want to take in one interval, let us say between 2 points, it is moved from here to here. The function value here to here. So what is the corresponding, let us say here the value is x is equal to, x coordinate is equal to, let us say here a. For the function here, for every value there will be x coordinate and there will be y coordinate. So here corresponding y is this. Y is, because our function is this, we will say y is equal to f of a. Now the function is moved from here to here. Here also corresponding x value will be there. Let us take a plus h here, and the corresponding y value is y is equal to f of a plus h. Now the function is moved from here to here, that means it has changed in some y and it is changed in some x. That is, here what is y value? F of a plus h minus f of a by x value is here, this is a plus h minus a. So a cancel and f of a plus h minus f of a by h. Right? Totally this is the value of this, the change in this y. Right? Now if we will define properly, what is it? Let I be an interval and here our function is in this interval only from I to R. I to R, and here we are taking a belongs to this I. We are taking a value a which is in this function interval, and I am taking mod h is not equal to 0, but it is sufficiently very small. Sufficiently small. Sufficiently small. So that means this h value is almost all, it is near to 0. It is tending to 0. That means here limit h tends to 0. What we got? F of a plus h minus f of a. This is difference of y. By difference of x's we got h. If this value is exists, then we will say this function is derivative, differentiable. Right? This function we will say differentiable. I think you almost understood. This is a function f of x and we are taking from this value to this value. For every value there will be x and there will be y. So x is equal to a plus h, its travel. Y is f of a to f of a plus h. Therefore the difference of y with respect to x is f of a plus h minus f of a by h. If this value is exist, then we will say it is a differentiable. It is a differentiable. And this total limit, what we will call is limit, we will say this value we will say derivable, or that is f of f dash a, right? So that means we will say it is a derivative. And how we will denote these derivations? We will denote it by, denoted by either we can say f dash a or we can say dy by dx, right? we can say in these forms. So it is a definition of derivation, and also it is denoted like this. Either we will say f dash or it will say dy by dx. Right? Now coming to next. Now we learn what is the differentiation or definition of the derivation. Definition of the derivation. Now we will say, let us say for the same function I will take. Okay. So let us say f of x. This is our f of x function. F of x function, y is equal to f of x function. Right. So now within this interval I am not taking any end points. Here I am taking this point. Here it between I only a. So because it is not end point, there will be left hand value will be there and right hand value will be there. Okay. So that means limit h tends to 0 plus f of a plus h minus f of a by h will be there. This we will call it is a 0 plus. So right hand derivative. We will say right hand derivative. Now let us say limit h tends to 0 minus f of a plus h minus f of a by h, and this we will call it as left hand derivative. You know what is it is just like left hand limit, right hand limit. This is already in chapter 8 continuity, right? So that same like that only. Here also we have left hand derivative and right hand derivative. If they both exist and left hand derivative and right hand derivative is equal, then we will say the function is derivative. The function is derivative. If the both are not equal, then we can say that the function is not at all derivative. Left hand derivative and right hand derivative should be equal. This is one of the important concepts. So we learned what is the derivation, definition of derivation, and some property, that is left hand derivative is equal to right hand derivative. Now we will go, and one more thing is, here we can say, suppose instead of limit of x tends to a, f of x minus f of a by x minus a, we can also say like this, right? Because h tends to 0, no? If h is equal to, we will say x minus a, and we will substitute in this, we will get like this. Limit x tends to a, f of x minus f of a by x minus a. This is also definition of derivation, f dash x. F dash x. Now we will go to the next one. That is, suppose if a function limit h tends to 0, already we know the definition of derivation, that is limit x tends to 0, let us say my point is x, f of x plus h minus f of x by h, this is equal to f dash x. This is the derivation definition, isn't it? This one, f dash x, this is also called as a first principle of derivative. First principle of derivative. This is one of the important concepts in this chapter. Right? So f dash x is equal to f of x plus h minus f of x by h. Limit is h tends to 0. This value if exists, then we will say this is derivative. The derivative value f dash x, right? And this is called the first principle of derivative. This is one of the important topics of this chapter. Now coming to next one. So here we will see some problems based on this first principle. Okay. So first we will do some problems. If f of x is equal to x square, x belongs to R, prove that f of x is differentiable, f of x is differentiable, and also find the derivative. Also find the derivative. Just now we learned the concept of derivation. Derivation is limit h tends to 0, f of x plus h minus f of x by h, right? So by using the first principle, we will find the derivative. First, we will check whether it is differentiable or not. Then we will find automatically, we will find f dash x. Now, what is our function? F of x is equal to x square. Now, here I will take f of x plus h minus f of x. Because our first principle is f of x plus h minus f of x by h. So, here x plus h whole square, because our f of x is x square. Here I am substituting x plus h, so that here x plus h whole square minus x square. This is just like a plus b whole square. A square plus 2ab, that is 2xh plus h square minus x square. Clearly here x plus x square minus x square will get cancelled, and what we can see is here h is common. By taking h common, here we have 2x plus h. Now in limit h tends to 0, this is our derivation principle. We should not forget this. This is the main concept. F of x plus h minus f of x by h is equal to here h into 2x plus h by h. So h will get cancelled, and what we have here, limit h tends to 0. So here limit h tends to 0, 2x plus h, this we got. So here now we will apply h tends to 0. That means h, we need to substitute h is equal to 0. H is tending to 0. So here there is no h. So simply we can write 2x and plus h value, there we can substitute 0. So that what we are getting, limit h tends to 0, f of x plus h minus f of x by h. This value we got 2x. That means we found some value, f of x plus h minus f of x by h. After applying the limit, we got 2x value. So if we are getting, that means limit is existing. Therefore, what we can say, therefore, f of x is differentiable. If we will get limit, then it is a differentiable. And what we got 2x. That will become our f dash x. F dash x is equals to 2x. F dash x is equals to 2x. Now, f dash x is equal to f of x is x square, and we got f dash x is equal to 2x. In other words, we can write, because it is a derivation, we already discussed, we denoted with dy by dx. Here, d by dx, so what is our function? X square. So x square derivative, we got 2x. So this is how we'll check by using the first principle, right? Here we took f of x is equal to x square, and we found limit h tends to 0, limit h tends to 0, f of x plus h minus f of x by h. By substituting the values, after cancellation we got 2x plus h, and h is tending to 0, so that we are getting 2x, right? So we are getting limit, that's why we will say f of x is differentiable. F of x is differentiable means we can say f dash x is equal to 2x. This is nothing but the derivative of x square, d by dx of x square equal to 2x. Now, to practice more, so we will do one more problem, okay? So what we will do is, we will check for sin x function. So this is a problem number 2, okay? Problem number 2, I will use another pen. So f of x is equal to sin x. F of x is equal to sin x. Prove that f of x is differentiable. F of x is differentiable, and also find f dash x, and also find f dash x, right? So just here also we will use the first principle, derivative of first principle. So what we will do here, generally first we find f of x plus h minus f of x. Here f of x plus h minus f of x, isn't it? So here f of x plus h, because our sine function is there, so here we can say sine x plus h minus sine x. This is just like trigonometric property, sine c minus sine d. So sine c minus sine d means here I am writing sine c minus sine d. You all know sine c minus sine d equal to 2 cos, wait a minute, 2 cos c plus d by 2 and sine c minus d by 2. This is our trigonometric principle. So here we will use that. So 2 cos c plus d means here x plus h plus x by 2 and sine x plus h minus x by 2. Right? Here x and x will get cancelled, and here 2 cos, here x plus x is 2x by 2 means here we will get x plus h by 2, and here we will get sine h by 2. Right? Now we will use first principle, that is limit h tends to 0 f of x plus h minus f of x by h. So that's why here limit h tends to 0, 2 cos x plus h by 2, and we got sine h by 2 by h. Right? So by doing it, what we will get here generally? So in h function here we can substitute, right? So limit, here 2 is number, so I am writing outside, limit h tends to 0, here h value I am substituting cos x plus h value is tending to 0, so therefore it is 0. And here for sine, here one more thing is there, limit h tends to 0, here what is remaining here? Sine h by 2, and in denominator h is there, that we will write here. Right? So here 2 cos x, and we know sine h by 2, just I am making like this, h by 2 into 2. Why I am making like this? This is a in continuation we have limits, standard limits are there. Limit x tends to 0, sine x by x value is 1. Right? So like that here it is applicable here, so that the value will become 1, and in denominator we have 2, and 2 and 2 will get cancelled. And in last what we will get is cos x. That means here f of x, and we will got f dash x is equal to cos x. That means f of x is derivable, and we got one function, that is f dash x. Simply we can say derivation d by dx of sin x is equal to cos x. This is one of the important formula. Like this, by using first principle, we can solve all the formulas, standard formulas in the derivatives. Okay. Now I want to say one more problem in this regarding. Let's see one more problem. Okay. So here, let us see one more problem here, right? F of x is equal to e power x. We will find the derivative of this one also by using the same first principle. As of now, you may be understood what is the procedure. Limit h tends to 0, f of x plus h minus f of x by h. Right? That means limit h tends to 0, e power x plus h minus e power x by h, because f of x plus h means e power x plus h. Now doing this, what we will get? Limit h tends to 0, e power x into e power h minus e power x by h. Right? So in both, common is clearly visible, e power x is common in numerator. So here e power h minus 1 by h. Right? So here e power x, there is no h, so we can write outside, and remaining is limit h tends to 0 e power h minus 1 by h. This is a standard limit formula. Limit x tends to 0 e power x minus 1 by x value you studied in continuous chapter. The standard value, this value will become 1. So that here e power x into 1, so that what you are getting e power x. Right? That means we took f of x is equal to e power x, and we found by using the first principle we got the derivative f dash x is equal to e power x. So simply what we can write, d by dx of e power x derivation, we are getting e power x only. Right? Likewise, in differentiation, what are the standard limits are there, that all we can do by whether it is log x, you can try it for log x, a power x. Right? There you can try this line. Log x, a power x, sin 2x, sin 3x, tan x, all you can do by using the first principle. Right? So this is the one of the important topic, and in IPE it is probably it is coming for 4 marks questions. Right? So most of the important topic by using the first principle, even in IPE it is coming for 4 marks question. Okay? Now we'll move into next one. Now already you know how to find the derivative, right? By using the derivative principle, right? Now we found f of x is equal to x square in the first one, right? You can see in previous one. Now here it is f of x is equal to e power x, right? Now in previous one we saw f of x is equal to sin x, and in previous we saw f of x is equal to x square. Right? F of x is equal to x square, sin x, and in the last we have done f of x is equal to e power x. Right? E power x. Likewise, you can practice so many questions. This is coming for IPE, that is log x and a power x for 4 marks. Okay? Now, we will see by using the first principle only we are derivating some derivations. This is very, very useful. So, you need to remember all the standard derivatives. So here I am writing the standard derivatives. Standard derivatives. What are the standard derivatives? These are the formulas, right, that you need to remember in the derivation chapter. So first, d by dx. This is a symbol already you know, right? Derivation is denoted by d by dx. d by dx of x is equals to 1. And second one, d by dx of x power n is equal to n into x power n. Students, you all need to note these formulas and you need to remember these formulas. Now here d by dx of log x. Log x is equals to 1 by x. And one more formula, d by dx of e power x is equal to, just now we completed by using first principle, e power x. And last one, not last one, sum of the principle, here a power x is equal to a power x into log x. These all can be attained by using first principle. And sum of the next d by dx of 1 by x is equal to minus 1 by x square. And next d by dx of 1 by x power n is equal to, right, here minus n by x power n plus 1. And one more formula, that is d by dx of 1 by root. So here 1 by root x is equal to, we can say, right, d by dx of 1 by root x is equal to, you can use this one, not root x. So 1 by. Alright. d by dx of root x is equal to, we can say, 1 by 2 root x. And one of the important one that we will use plenty, d by dx of any constant value is 0. Because constant means there is no change. So always derivation of constant value will become 0. These are the important formula that you need to remember in this particular chapter that will be useful in doing your problems. And these are all standard derivative formulas. Now we have derivative formulas in trigonometry also, right? In previous only we have done, so we will do some derivatives of trigonometric functions. derivatives of trigonometric functions. Trigonometric functions. These also you need to remember, right? Our trigonometric functions are sine, cos, tan, cot, and sec and cosec are there, right? So all these formulas you need in your problems. That is d by dx of sin x is equal, just now we solved it. D by dx of sin x is equals to cos x. And similarly, d by dx of cos x will become minus sin x. And d by dx of tan x is equal to sec square x. Okay, sec square x. And next, fourth one, d by dx of sec x is equal to, it will become sec x and tan x. And the fifth one, d by dx of cot x equal to minus cosec square x. And here sixth one, d by dx of cosec x is equal to minus cosec x cot x. These are the trigonometric derivatives that are useful in your problems while doing the problems. Now we completed some standard derivative formulas, and also we completed the derivatives of the trigonometric functions. Sin x, cos x, tan x, sec x, cot x, and cosec x. Okay, now we'll go for some elementary properties of the derivatives, right? So elementary properties of derivatives. These concepts are very, very useful. That's why I am saying this elementary property. If you will understand properly, it will be useful in solving your MCET bits, and the concept is very, very important. First, understand concept of derivation, and now we are going to do some theorem. What is a simple theorem, right? So, what is the theorem? First, let I be an interval, right? Function is from I to R, that you already know. The function is from interval to real number system, right? F is from I to R, and I will take some A in this interval only. A belongs to I, and what we are saying is F is differentiable. F is differentiable, that we know, right? F is differentiable at which point? At A. F is differentiable at A. Then we need to prove that F is continuous at A. F is continuous at A. That means if F is differentiable at A, we need to prove that F is continuous at A. So already we wrote the formula, right? Limit x tends to A, derivation formula. F of x minus f of A by x minus A, it is nothing but f dash A. Isn't it? Now we'll solve, we'll check whether it is continuous or not. So by doing f of x minus f of A, this f of x minus f of A, I am writing like this: f of x minus A by x minus A into x minus A. Now x minus A will get cancelled, and we'll have the same one, f of x minus f of A. Now here, so I will rub this one. Right. So here, now we will apply limit x tends to A, f of x minus f of A. Limit x tends to A, f of x minus f of A. That is, limit x tends to A, f of x minus f of A by x minus A. And here also we have limit x tends to A. Here one more is there. Here also we need to apply the limit. So by applying limit, A minus A will become 0. This part will become, by definition, this is f dash A into 0. That means the total one will become 0. What we are getting? We are getting limit x tends to A, f of x minus f of A. The total value will becoming 0. Right? That means limit x tends to A, f of x is equal to this f of minus f of A will go to right hand side, and it will become as limit f of A. That means limit x tends to a, f of x is equal to f of a. What is the meaning? This is 9th chapter, and previous chapter is continuity. The basic definition of the continuity is this one only. The chapter starts from here only. What is the, if limit x tends to a, f of x is equal to f of a, then automatically the function will become continuous. That means f is continuous. So our theorem is proved. What is our theorem? If f is differentiable, then automatically f is continuous at a. F is differentiable, so that it is becoming f of x is equals to f of a. That means it is becoming as continuous. So hence the theorem is proved. That means you need to remember one point. What is the point? If f of x is differentiable, automatically the function will become continuous. But the converse need not be true. Right? Let's see that one also. Right? We already proved in the previous theorem that if f of x is differentiable, automatically it will become f is continuous. Now, but the converse need not be true. What is the meaning of it? If f is continuous, if f is continuous, then f is need not be differentiable. Need not be means it is may or may not be differentiable. Sometimes it is differentiable, sometimes it is not differentiable. Where it is not differentiable, we will prove this one by one problem, right? So I will choose one problem to prove this. F of x is equals to mod x. This function I want to take, right? To explain this line. If f of x is continuous, but f of x is not differentiable. F of x is mod x. What is the graph? Let's see. This is x coordinate, this is y coordinate, and this is 0. And f of x is equals to mod x. Excuse me. Okay. F of x is equal to mod x. So this is the graph of f of x is equal to mod x, because this is our function. F of x is equal to mod x. This is the graph. What we said? F is continuous, but it need not be differentiable. How? Let's see. When I am drawing the graph, you may be observed that. So here f of x is equal to mod x. I didn't lift my pen. Right? That means it is going continuously. That itself is telling that it is a continuous function. Right? So now we will check the differentiability. Right? What is the differentiability? F of x is equal to mod x. Where we will check? We will check at this point. At x is equals to 0. We will check. Right? So by using the same principle, first principle only, because the basic definition of the derivative is that, right? So limit h tends to 0, f of x plus h minus f of x by h. Right? Here, limit h tends to 0, we are checking derivation at which point? At x is equals to 0. So that's why we can substitute x is equal to 0. By substituting that, we will get 0 plus h minus f of, this is 0 by h. So 0 plus h means h only, that is limit h tends to 0 f of h minus f of 0, because our function is mod function. F of x is equal to f of 0 equals to mod 0. Mod 0 value automatically it will become 0 by h. Right? What we are getting in last? Limit h tends to 0 f of h by h. This we are getting. Right? But what is our function? F of x is mod x. So similarly f of h will become mod h. What is the mod h function? The mod h function, it is from 10th class itself, right? Mod h means either it is minus h when h less than 0, or it is plus h when h is greater than 0. You can see from the graph also. If less than 0, you are getting negative value. Greater than 0, you are getting a positive value, right? So by using this, we can, so this here we will get two values. Limit h tends to 0, right? F of h. F of h means here we can get two values. Either here minus h when h less than 0. So automatically it is becoming minus 1. It is plus h. So it is getting us plus 1. Right? Plus 1 when h is greater than 0. That means here you can see minus 1 and plus 1, isn't it? That means we are getting two derivatives for the same function. It is LHL, LHD left hand derivative, what we are getting? Minus 1. And what is the right hand derivative we are getting? Plus 1. Right? That means here clearly you can see that is minus 1 and this is plus 1. They are not equal. So obviously left hand derivative is not equal to right hand derivative. Once they are not equal, that means derivative does not exist. That means f of x is not differentiable. It is a continuous function, right? Continuous function. By using the first principle, what we got that f of x is not differentiable, right? So f of x, so previous theorem is f of x is differentiable, then it is continuous. But here what's happening? F of x is continuous, but it need not be differentiable. It may or may not be differentiable. That is the difference that you need to remember. Now we'll go to one more. Right, what are the things? So you can do some problems also in this regarding, okay? This may become for your answer examination. What is this? Let's check this with your, right? F of x is equal to 3 plus x and 3 minus x, right? Here it is containing two values. At which point? The point is 0 only. X greater than or equal to 0 and x less than or equal to. Previously I have done models. Similar process you also can check, right? So this is homework as you need to do this one, right? This concept is coming for MCET, right? So you can use this one. That means you need to find left hand derivative, you need to find the right hand derivative. If both are not equal, then automatically this will become, this is not a derivative, at which point the point is 0, right? So I hope you will all try it, okay? Now we'll go move to next topic. Okay. I hope you all will try it. It's very simple, right? Derivative here you can see f dash x is equal to 1, here f dash is equal to minus 1 we will get, and that you can do. So the same procedure, f of x is equal to modus I have done. In the same procedure you can try for f of x is equal to 3 plus 6 and 3 minus x. Now we will go for further topics, right? So what are the topics? Right, let's see. Before doing the topics, problems, now we are going to do some functions derivative, basic principles of the derivations, right? So for what we learned f of x is, what is the derivation principle, right? Basic definition of derivation, and in next what you learn, left hand limit and right hand limit. And afterwards, using the first principle, we solved some basic principle, e power x sine x, x square, and we learned some formulas, right? And we checked both, if f is differentiable, then it is continuous, the vice versa is not true. Moving on to the next one. So what we are going to do is, here, now we are going to learn some properties, basic properties that we will use in the derivations, okay? Now, derivation principles, you can say, right? Principles or rules, okay? Rules for functions, two functions. That these are the compulsory. So what are the compulsory? Remembering all the formulas, derivation formulas, and as well as this is the derivation of these two, right? Let's take two functions, u of x and v of x. These are the functions, clearly they are in x. So these are the basic principles that we will use in our differentiability. What are they? So first one is u plus sum of two functions derivative. U plus v whole dash. This dash is also denoted as derivation, right? Remember that. So simple, this is u dash plus v dash. The same is applicable for u minus v whole dash. So this is u dash minus v dash. And third one is here uv whole dash. That means uv means u into v. What is the derivation here? U dash v plus uv dash. This is also known as product rule. These all formulas, whatever I am writing on the blackboard, so these all will be used in during doing problems. Okay. Now here, and for this uv, not only uv, uv, w, x, y, z. What are the products? Let's say I am writing one more. uv, w. Right? uv, w means. So while doing the product rule, you need to remember that if you do one derivative, the remaining are constants. If I am doing v derivative, then u and w are constants. If I will do w, then uv are constants, like that. uv, w, x, y, z, whatever may be, how many functions are there, we can use this product rule while doing the problems. Right? Now, for this corollary only, one more formula is coming up that I am remembering. Alpha u plus beta v, let's say, whole dash. What is this? Alpha and beta are constants. So if constant, we will not apply. Just we will write as it is alpha and u dash plus beta and v dash. Right? And the last one is here, the place is not enough. Here I am writing the fourth one. Okay? So this is u by v whole dash. U by v whole dash means denominator will write as it is v u dash minus u v dash by v square. This is also called as quotient rule. This is also called as quotient rule. So these are the basic principles or rules that we will use in our doing problems. U plus v whole dash equal to u dash plus v dash, u minus v whole dash equal to u dash minus v dash, u v whole dash equal to u dash v plus v u dash, and u by v whole dash equal to u dash v minus v u dash by v square. This is quotient rule, this is product rule. Where we will use, in each and every problem we will use these all formulas. So that's why you need to remember all these formulas. Okay? Right. Now we'll go not only theory, we are going to learn some problems and we'll see some MCQ questions also. Okay? Right. Here we will do some problems and one more fifth rule is there, that also we will use. Here I am writing that fifth rule. Why we should write? We will write in the previous one only. Maybe this one. Right. So here, this is a fifth one. Right. In this fifth one, what is the rule is, it is not exactly rule, it is called as a chain rule. Right. If z is equal to f of y and y is equal to f of x, right, this is called as chain rule. Chain rule. If suppose we want to say, we will want to find dz by dx, right, dz by dx. dz by dx means here z is not function of x. What we will do? First we will do dz by dy and into here dy by dx. That's why it is called as chain rule. Because every time the function may not be in x. Sometimes it may be in y, it may be in t. So in that process we will use this chain rule. Okay? Right. Moving on to the next one. Now what we will do? We will do problems, okay, based on these all formulas and right. So here till now we learned all the formulas and some theorems regarding this derivation chapter. Now we will go for the problems. So let's see one problem. So we will start with a simple one. So here f of x is equals to ax plus b whole power n. Ax plus b whole power n, and here we will find what we will find? We will find f dash x. Find f dash x. This is the problem for 2 marks or 4 marks, right? So basic problem, I want to start with this one. F of x is equal to ax plus b whole power n. So directly we cannot find this, it is not a formula. What we will do? Whatever the bracket in this, let us say let it is u. U equals to ax plus b. What's happening now? Our function is changing. F of x is equal to, it is becoming as u power n. Right? Now we will do this derivative, right? F dash x. F dash x. because it is function n into u power n minus 1. We learn the properties, right? D by dx of x power n is equals to n into x power n minus 1, right? So by using the same principle here, n into u power n minus 1, again here u is there, so that's why we will do du by dx. That means n into u power n minus 1 d by dx of ax plus b. Ax plus b. So here n into u power n minus 1 d by dx of x. Here a is constant, that's why a, and the derivation of x value will become 1 plus derivation of constant value will become 0. So here n into what is u? U means ax plus b whole power n minus 1. By doing it here you will get a. Simply an into ax plus b whole power n minus 1. This is our f dash x. Right? See, in each and every step we are using some or other formula. F of x is equal to ax plus b whole power n. Here we are using f of d by dx of x power n equal to n into x power n minus 1. Now here derivation, here we are using chain rule du by dx, and here we are using, right, corollary a, and d by dx of x value is 1, and here we are using d by dx of constant is 0, and like that we are doing, right? That means most important thing in the derivative is you need to remember the formulas very well, right? This is a simple problem, that's why I started with this. Now we'll go forward. Next question is, we will one by one, right? We will explore all the formulas. We will explore all the formulas. What are the formulas? So, second question. F of x is equal to e power x into x square plus 1. F of x is equal to e power x into x square plus 1. Right? So here also we will do, right? Here e power x into x square plus 1. So here we have two functions. So this we will say u of x because it is two functions. One is e power x and the other is x square plus 1. Right? How the function is changing? The function is changing like this. F of x is equal to u into v. U into v. U into v means we can apply product rule. What is the product rule? Just now we completed uv. Derivation of uv is equal to u dash v plus uv dash, isn't it? Right? Now we will use that one only. F of x. So first before doing that we need to find u dash and we need to find v dash. So here doing it, right. So here first we'll find u dash. E power x derivation, just now we completed in the formulas. E power x derivation is e power x only. Right? Then we will do v dash. Here two functions are x square plus 1. X square plus 1 means it is looking like x power n. Derivation of x power n is just now we completed, will repeat n into x power n minus 1. So here like that, here 2 into x power 2 minus 1 is 2x. Plus here 1 derivative is 0, right? So u dash v dash. Now coming to f dash x is equal to, we need to find the derivative. U dash means here e power x into v, that is x square plus 1. Plus here next what it is? Formula uv dash. uv means here e and v dash means here 2x. By taking e power x, visually it is clear, e power x is common, here x square plus 1 plus 2x, isn't it? Right? Simply we can write e power x into, this is nothing but a plus b whole square, it is so x plus 1 whole square. Right? So we are learning step by step. First we learn basic, right? Now we are using product rule. Now we will go for one more problem using u by v, that is quotient method. Okay? Now let's see. Third, here here what I will take? F of x is equal to here a minus x by f of x, or we say y, okay, no problem. Here a minus x by a plus x, a minus x by a plus x. Now we will find the derivative. Alright, so how we will find the derivative? It is looking like u by v. It is looking like u by v. Some function is in numerator, some function is in denominator. It is looking like u by v derivation. What is u by v derivation? First, I already told you v u dash minus here u v dash by v square. This is the derivation. Right? So here also dy by dx, this is derivative of v u dash. So here a minus x derivative, is a derivative is 0. At first we will write v, a plus x into, this is a minus x, a is constant 0 and x derivative is 1, minus u is here a minus x and v derivative here a derivative is 0 and x derivative is 1 by v square is here a plus x whole square. So here a plus x into minus 1, isn't it? So minus here I am writing minus here a minus x by a plus x whole square. So by doing here minus a minus x, a minus x by a plus x, isn't it? v u dash minus u v dash by v square. So here minus a minus x and here also minus a minus x by a plus x. So clearly here minus 2a minus 2x by a plus x. In both we can take common minus 2. So that's why here a plus x by a plus x square. Square and one term will get cancelled and in last what we'll have? Minus 2 by a plus x, right? Isn't it? So like this we will do u by v problems. So 1-1 model I am saying. So first we started with the simple derivative, then we have done for uv and now we have done for u by v. That means we are checking each and every. We are checking for simple property and then product rule and then quotient rule, isn't it? Now we will forward one more. F of x is equal to, right? F of x is equal to, here you can see so many examples in this, okay? Right. The question number is, I forgot what is the question number. Previously we have done 3 and now it is 4. Right? F of x is equal to under root of modulus of 1 plus x square by 1 minus x square, right? 1 plus x square by 1 minus x square. This we need to do the derivation, right? How will we do this? This entirely it is a big one, so that's why simply what I am saying is, let's say u equal to 1 plus x square by 1 minus x square, okay? Question. Then f of x is equal to, it is becoming like root u. By doing the derivation, here f dash x is equal to, we have 1 by 2 root u and u is coming, so that's why here what we will do, du by dx. This du is this function, isn't it? We will do that one. So here separately I am doing this derivation u dash. This is just like u by v, right? U by v means v u dash minus u v dash by v square. So here v as it is we will write 1 minus x square and this is 2x minus here 1 plus x square and here minus 2x by here 1 minus x square whole square. Okay, so here by doing this what we will get, 2x minus 2x cube, here minus into minus plus 2x, here plus 2x cube by 1 minus x square the whole square. These both terms, what are the terms? no, not this. This one and this one will get cancelled, and here 4x by 1 minus x square whole square. So applying here, f dash x is equal to 1 by 2 root u. 1 by 2 root u means here 1 plus x square by 1 minus x square, and this is 4x by 1 minus x square whole square. Right? Further like this we can solve the questions. Okay. Now we'll see some important previously 23-24 questions, MCET questions I want to say, right? So let's see one questions from MCET. Okay. What is the question? In previously it is in 2024, right? Last year question only, right? So we will see one model of it, right? What is the question? Is a particle is moving. A particle is moving. A particle is moving from a fixed point. From a fixed point on a straight line. On a straight line. Fixed point on a straight line, and it travels a distance, right? The distance is s is equal to t cube minus t square minus t plus 2. This is the distance which is travelled in t. What is the question is, when it comes to rest, what is the distance it travelled? This is the question. What is the distance it travelled? This is in 2024, I think, 2024 question, right? Answer question. So here, first thing is, we need to find when it comes to rest. When it comes to rest means it is moving. There is no movement. So first we need to find the velocity. What is the velocity? ds by dt, distance by time. That means we need to find the derivation of d by dt of t cube minus t square minus t plus 2. By using x power n formula, t cube derivative will become 3t square minus t square derivative will become minus 2t, and this will become minus 1. What is the problem saying? When it comes to rest. When it comes to rest means the velocity will become 0. Velocity will become 0 means 3t square minus 2t minus 1 equal to 0. So by doing factorization, we will split the splitting method. 3t square minus 3t plus t minus 1 equal to 0. So by taking 3t common, here we will get t minus 1. Here taking 1 common, here we will get t minus 1 equal to 0. From this, here t minus 1 and 3t plus 1 equal to 0. So from this you will get t is equal to 1 and t is equal to minus 1 by 3. But what is t? T is time, it need not be in negatives. So we will not take this, and this is a positive value, t is equal to 1. What is coming to the question? When it comes to rest means v value, velocity is 0, is coming to rest. The particle is coming to rest means it is v equals to 0. By v equal to 0 we are getting time, t is equal to 1. So in this time, what is the distance it travelled? S is equal to t cube minus t square. So t cube means here we got 1 cube minus 1 square minus 1 plus 2. By solving it, 2 plus 1, 3, isn't it? 3. Okay. 2 plus 1, 3, minus 2 is equal to, right. So here we will get 1, right? So that means 1 meter distance it is traveling. Like this we will solve the questions, right? Now we have time, we will see one more question from previous MCET questions, okay? So I hope today what we learn, we just will revise. Right? First we started, this is the chapter, 9th chapter 1b, that is differentiation. In this differentiation we started with what is definition of derivation and left hand limit, right hand limit. Then we see first principle. By using first principle, we solved some standard derivative formulas, and after that we wrote some standard derivative formulas and trigonometric formulas, and we discussed f is continuous, then it is differentiable, but f is differentiable, but it is continuous, but f is continuous, it need not be differentiable. After that, we have done some rules, right? Basic rules of two functions, that is product rule, quotient rule, and chain rule. And we took for each model, we took one problem and we solved it. And we saw one MCET questions. If time permits, we will see. You can see one more question also.
So, that you can call to the number which is stored on the screen.
Students, you can call the number which is on your screen. Okay? If you have any doubts, you can call to the number.
We will be explaining the class.
Okay. Now we will see one more question from the previous one. Okay? So this is one more question from MCET only. E power x is equal to y plus under root of y square minus 1. Find dy by dx. This is an, I think, 2023 question. Right? Previous question. So here e power x, derivative is e power x. Right? So here y derivative is dy by dx plus here root x model. Root x derivation is, we will already learn the formulas. Root x derivative is 1 by 2 root x. So here 1 by 2 root y square minus 1. And again here y square minus 1 derivative, we need to see d by dx of y square minus 1. Okay? So here dy by dx plus 1 by 2 root y square minus 1, and this is 2y into dy by dx. Right? In both dy by dx is common. So by taking dy by dx common, on this side we have e power x. Okay? So what is e power x? E power x is nothing but y plus under root of y square minus 1. And here dy by dx, here 1 is common. By taking dy by dx common, here 2 and 2 will get cancelled. We have y by under root of y square minus 1. Now here dy by dx is equal to, here under root of y square minus 1 is there, and here by cross multiplication this will become under root of y square minus 1 plus y. On this side we have y plus under root of y square minus 1. So both same terms will get cancelled, and by cancelling here we have 1. So 1 into this one, here will go this. So dy by dx is equal to, we are getting answer is under root of y square minus 1. So like this we will solve. Okay? Let's see one more question. So we will see one more question. The time is there, so that's why we will see, right? So this is also from previous question only, MCET question, 2023 question. Right? What is the question? Let us see. This is third question, right? So if sec of log base 2 log y square base 2, okay, log y square base 2 is equal to, here cosec of log x square base 2, then find dy by dx. This is the question, right? MCET question. So how will we solve it? Sec of log y square base 2 is equal to cosec, we can write it as sec 90 minus theta is cosec. So that's why 90 means 5 by 2 log of x square base 2. Both sides sec will get cancelled, and what will have? Log y square by 2 is equal to, on the right hand side, pi by 2 log of x square base 2. I'll keep constant here, I'll bring out this term to here. So that is log y square base 2 plus log x square base 2 is equal to pi by 2. This is basic principle, log n plus log n. So log n. So here log, here mn means here x square and y square. What is base? Base is same 2 and pi by 2. Right? This is basic logarithm principle that you studied in the 9th class, isn't it? Log of x base a is equal to b, then what we can write? X is equal to a power b. Right? So from this, here x square and y square, simply we can write xy whole square. This will become power 2 power pi by 2. 2 power 2 is constant, pi by 2 is constant, we will get a constant value. So let's say that is constant c. Right? So here, what we are getting? Xy equal to square means xy will become plus or minus under root of c. Again under root of c, this is a constant value. So again for simplification, it is a constant, so that xy is equal to k. Now we will do the derivation. So derivation of d by dx of xy is equal to d by dx of k. So UV model, first u dash, derivative of x is 1 and this is dy by dx plus x derivation. So where we started? So here already have done derivation of u. So we need not do this. What we will do? We will do y plus here x into this is dy by dx and the constant derivative is here 0. So here plus y go to that side, x into dy by dx is equal to minus y and dy by dx is equal to minus y by x. Right? Minus y by x. So like this, whatever the given problem is, we will use the appropriate method and we will find the derivative. Right? We will see one more question in a different model. Right? So, right. So here, question number, maybe it is 4. Okay, I am writing 4. So x is equal to log p. X is equal to log p and y is equal to 1 by p. Find dy by dx. This is also previous MZ question only. Whatever I am telling is the previous MZ questions only. Okay. So here x is equal to log p and y is equal to 1 by p. X is equal to log p means p we can write it as e power x and y is equal to 1 by p. Now we need to find dy by dx, isn't it? Find dy by dx. This is our question. So dy by dx, but here speed if it is in variable, so that's why we will find dy by dp minus 1 by p square and p derivative is dp by dx and minus 1 by p square dp by derivative of this one is e power x only. Right? So here, right, p is equal to e power x derivative 1 by here e power x whole square into e power x, when will get cancelled, e power minus x. Right? This is dy by dx. So dy by dx. Any questions? Call to the number which is on your screens. The session is going to close. Right? We will see one more problem. Okay? Same question only, inside question only I am saying. Right? Right. So we'll take so maybe pick the question. If tan y equal to cot pi by 4 minus x, then find dy by dx. Then find dy by dx. So here previously we have done similar model. It is again coming tan. It's called, we can write tan 90 minus theta. Or here y is equal to pi by 2 minus pi by 4 plus x. So here doing the derivation, dy by dx is equal to constant derivatives are 0 and x derivative is 1. So like this we can find dy by dx. Right? I hope students you understand the derivation topic. This is very important topic in point of MCET point of view. This is the chapter 8. In calculus you will continuously have a derivation and up to applications of derivation in 10th chapter. So today we touched some introduction part and also we touched some problems which are coming in our MCET examination, previous questions. Right? I hope you all understood. Right? Whatever I gave, those problems you can try by using first principle and you can solve all the questions from 9A, 9B and 9C in your exercise. That is going to come in your IP examination.